Indices are essentially indices with a fraction. So it looks scary, but a rational index would look something like this, 7 to the power of a third. They're a little ugly, and what it's important for us to remember is that rational indices are essentially the same as surds, or are very much related to surds in the following way. For example, x to the power of a half is the same as the square root of x. Now normally we wouldn't even write the 2 in there, we would just write that as root x. But given a blank out here, we know it's the square root. Similarly, a to the third is the cube root of a. Now, what happens then when you have b to the 2/3? And if we want to express that as a surd, we could think of that as b to the third times 2, or b to the 2 times a third. Because we're all happy that a third times 2 is the same as 2 times a third, and both of those are equal to 2/3. So one of these is going to be quite useful for us. I would choose this one. I would think of that as b squared to a third. Meaning that will be the cube root of b squared. So this is equal to the cube root of b squared. And using this rule, and in fact these rules here, you would be expected to be able to manipulate numbers using surds, roots, fractional powers, etc. And we'll do some examples following. So, you write them down. What annoys me is that this is cut straight from the textbook, and in most cases the index laws apply to rational indices. No, most cases is completely wrong. They're laws, they apply to every case of indexes. Alright, so, when my computer stops freezing, we'll scroll down. Express the following in index form. Generally, it's much easier to work with numbers in index form because our index laws apply, so we try and get that out of surd form into index form. Expressing this in index form, the 6 is just there to confuse us. We'll leave the 6 out the front and remember it's 6 times. Then, we'll remember that this here means really to the power of a third. So this reads as 6 times n to the 7 to the power of a third. So how to simplify that? Well, power raised to another power multiplies. So that leave the 6 times n to the power of 7 to a third. Now 7 to a third is, 7/3. So it'll be 6 times n to the 7/3, and our answer is just that. 6n to the 7/3. Similarly, the 2, once again, there to confuse us. Leave it out the front. Remember the 3 is the third. A to the 4, b to the 2 to the third. 2, a to the 4 on 3, b to the 2 on 3. Just algebraic legwork. Alright, here comes a more interesting type of algebraic legwork. Evaluate without using your calculator. Alright, firstly, negative indices are really no fun, so let's rewrite that as a positive index. 1 over 27 to the 2/3. Now, we recognise that 27 has got something to do with 3, so let's see what happens when we get it by itself. So you should know that the cube root of 27 is 3 because 3 cubed is 27. 3 times 3 times 3, 3 times 3 is 9, times 3 is, 27. So if we can get somewhere the cube root of 27 out of this, we can reduce that to 3. Aim of the game. Let's see how we go. That is going to be 1 over 27 cubed squared, because 2 times a third is 2/3. Now, 27 to the power of a third is the same as the cube root of 27, which is 3. So that's really 1 over 3 squared, or 1/9. Yeah? Now, it takes practice to be able to spot that 27, when you cube root it, will drop out nicely. And this is why we're going to do practice on this type of thing. Alright. It also helps if you know what basic squared numbers are and what basic cube numbers are. They come up again and again and again. It's a lot like learning a new vocabulary. They will just start through repetition sinking in. Alright. Similarly here, for example, you should see straight away that, well, there's a 2 there somewhere, and I know 10 squared is 100, so maybe I can use that. Alright, let's see what we do. So, leaving the 10 at the top for now, because we can't really simplify much there. Please don't be tempted just to cancel out a 0 like that. You can't do that, because that process uses division, and in order to break in to division, you must deal with the powers first. Because in BIDMAS, indexes come before division. So leave the 10 at the top and write that as, let's go with 100 to the power of a half to the power of 3. Now, 100 to the power of a half is the same as the square root of 100, which is 10. So really we have 10 over 10 to the 3. Now it gets more interesting, because you have 10 to the 1 over 10 to the 3 will be 1 over 10 to the 2, which is 1 over 100. So written and simplified evaluated. Lovely. Once again, I'll remind you of the quiz we're doing this week. Now you should be able to do the entire quiz, because it had fractional indices as well as growth and decay. So that'll be due by Thursday. Good luck.